Hello, hello, hello. Today is Monday, May 18, 2026. Here follow Ulf Heller's solution to problem 255, with notes from Keith Norman. The problem is about relativistic Doppler shift between the moving of the star and the observing frame of the Earth. And I covered that in my lecture 35 of 802. And this problem is similar to my problem 108. The only difference is the values of beta. So here you see a picture. It shows you beta. It shows you an angle of alpha. Gamma is the Lorentz contraction of time dilation, and it is independent of alpha. Thus, when alpha is 90 degrees and 270 degrees, there is still redshift because of gamma. So if you want the redshift and the blue shift to be the same, then Fr divided by Fs must be this. And if that is smaller than 1, there is redshift. And if it is larger than 1, there is a blue shift. However, if there is no redshift and no blue shift, then Fr divided by Fs is 1. So this quantity must be 1, and this is gamma. So, Highschool solutions for the value of alpha gives you then that alpha is 98.8 degrees, but also an alpha is 261.2 degrees. So an alpha is 98.8 degrees, or when alpha right here 261 degrees. This would be 270. This angle is smaller, 261 degrees. So there are two angles for which the blue shift is the same as the red shift. If the angle of alpha is 90 degrees or 270 degrees, then there is always redshift because of gamma. And we call that transverse Doppler shift. So for angle 90 degrees and 270 degrees, the ratio Fr over Fs is still 1 over gamma. And gamma is always larger than 1. And so there is always transverse Doppler shift, which is redshift. How many of you have this right? Hard to tell. I give the right solution in problem 108. Only a different value for alpha. My guess is that maybe 15 people have this problem right. I want you to emotionally prepare for problem 256, because there is a lot of time for you, and you may already now start watching the first lecture in my list of interviews. So click on my playlist of interviews, and then there is the very first lecture, which lasts about 1 hour and 52 minutes. It's an interview with Larry Galligan. And I advise you to already start reading it now. And what our questions will be, well, I will post those when I post problem 256.